linear inequalities. Linear means it's x to the first power. Notice how we have x to the first power here, and that's where everything is really nice. It's when x is not to the first power that things start to go south for a lot of us. So as we solve this, we would solve it just the way that comes normal. We would add 7 to both sides. Get a negative 2x is less than 16. And then we have to divide by negative 2. Does anybody recall what you have to do when you divide by a negative? You have to flip the sign. Do you know why you flip the sign? It has to do with our number system. I'll give you just an example. We say 2 is less than 3. Watch what happens if I multiply both sides by a negative. I get negative 2 and I get negative 3. How does negative 2 compare to negative 3?
Negative 2 is greater.
It's greater than. So notice that on the negative side of the number line, things switch compared to what you think, right? Like 3 is bigger than 2. It would seem like that would be the same case. But just the way our number system works, we could design a different number system, but that's just the way it is. So just comes to the design. You can write the graph. Is it an open or closed circle? It is an open circle, and then the interval would be from -8 on to infinity. And I will ask for the answers to be written in interval notation. So interval notation is really what I'm looking for right there, okay? So you guys will be able to handle linear inequalities with no big deal. One question that you seem to generally have, and today is more of that review, tomorrow is all brand new, but one review that you need help with is compound inequalities. And a compound inequality has more than one inequality. So when you see this, this is a conjunction. There is an expression that's kind of grouped in between -9 and 11. We set up one inequality of -9 less than 3x minus 7. And then we set up another inequality. And that inequality is 3x minus 7 is less than or equal to 11. Everybody okay with that step? Now we just solve both independently of each other. I add the 7 to both sides, and I get -2 is less than 3x. I divide by 3. I get -2/3 is less than x. Now, there's nothing wrong with struggling from time to time with the inequality sign. But the fact is, this inequality sign here, if you read it from left to right, it reads -2/3 is less than x. Whereas if you read it from right to left, it reads x is greater than -2/3. I like to write it x greater than -2/3. Next one, just like normal, I add the 7, 3x less than or equal to 18. Divide by 3, x less than or equal to 6. I plot 6, plot -2/3, open circle, closed circle, arrow comes together. On the test, I don't expect you to necessarily draw the graph. I will ask for the answer in interval notation. I just think that when you draw the graph, it helps make sure that you get the interval notation correct, -2/3 and 6. Review, right? Seen that before? What's different about the next one? Yeah, they're separated with an or symbol. That's going to mean that it's a disjunction, that they go apart from each other. If you divide both sides by -4, we get x greater than -2. And if we add 3 to both sides, we get x less than -5. What is wrong about my setup right now? Yeah. Do you understand why people would put a -5 there? I've made that mistake multiple times before. You know, the -5 is already off to the right, and 5 is bigger than 2. But with our negative system, you know, things change. So you should write this as a -5 and a -2. X greater than -2 or less than -5. Our solution set here should be from negative infinity to negative 5, union negative 2 to infinity. This union symbol is something we used in the first unit, and you should use it when you have more than one interval. One class kind of fought me one year. They said, do we really have to write the union? That seems like a lot of work. If we think writing the union symbol is a lot of work, it's going to be a tough semester, everybody. Yeah, just write the U. You'll be okay. Okay. You flip it over. How'd the current events test go? All right. Was the current events test about current events, or was it about 9/11? It was. Okay. All right. Just never know. Glad it went well for you. Before we talk about some of the rules of the absolute value inequalities, we're going to do a couple together because I know that this is somewhat familiar to you. How would you start letter A if you didn't know what you were doing? Just add that 9 to both sides, and we get the absolute value of 2x minus 3 is greater than 30. Great. Absolute value means I set up how many? I set up 2. So I have 2x minus 3 is greater than 30. Does anybody know the next inequality I set up? Hint, 2x minus 3? Less than? Negative 30. So you do change the sign for both the number and the inequality. Now we solve both. Add 3. 2x greater than 33. Divide by 2. X greater than 16.5. Add the 3. 2x less than negative 27. Divide by 2. X less than negative 13.5. As we plot these, I plot 16.5. I plot negative 13.5. Notice we have open circles in both scenarios. Less than the 13.5 and greater than the 16.5. The graph gives me a clear indication that this is a disjunction. Negative infinity to negative 13.5. Union 16.5 to infinity. Please try letter B on your own. And when you get a result, please compare it with somebody next to you, see if you seem to have it correct. I'm going to hand out your packet of homework for this unit as you're working. By the way, I forgot to announce the other classes, but we are going to need to come up with some graphing calculators in this class. So if you don't have one, you can rent one. I have some forms that you can give to Ms. Hanson for rental. The rental fee is $20. We've been running this program for about 16 years where people can rent calculators. It's quite a good deal if you don't want to purchase one. Maybe you have a sibling who you can borrow one from. But you are going to need one for this unit. We'll teach you how to use it. We'll have a day of calculator exploration. But you do have questions on this next test that cannot be solved unless you have a graphing calculator.
You're adding two and then subtracting two. Oh, yeah, we're just subtracted two.
Did I do it correctly?
Oh,
Getting some nods. Sophie, do you know what your name means? It means wisdom. Wisdom. You guys all know what your names mean?
No.
Who does here know what their name
wait,
is?
I think-
What does Alex mean?
I'm a warrior.
A warrior. What does Hannah
Alexander
mean?
the Great.
Favor or grace?
Favor or grace? You should try to discover what your name means. Sophia is Greek for wisdom. We just know that. Like the sophisticate, preface of it. Okay. So let's talk about some of the rules of the inequalities, because when you get absolute values and inequalities, I'll be honest, some of our conventional ways of solving it kind of goes out the window. You've got to think outside the box, and you have to start to think logical. Some people can do this, some people can't, but we'll do our best. First of all, if you end up with an absolute value less than a constant, what I try to think of this is less than. The and, as I put emphasis on that, if you notice in this situation, notice how the symbol was a less than. That was a conjunction where they came together. So when you got an absolute value, you can look at that. If it's a less than symbol, you know that they're going to come together. Whereas if you see this symbol, you would say great or. Instead of greater than, I think great or. And that means a disjunction. They're going to go apart. And if you look at the example we covered right here, notice that you have a great or than sign. Whoop, gosh, wow, tricky. Where are you? Okay, there we go. Notice in this situation you have that great or than sign, and so you get a disjunction. You don't have to do that, but it could be a nice way to kind of check your work and see if you're right or you're wrong. But the next ones you've got to think about. You've got to really use your brain. And look at this next expression. It says the absolute value is greater than a negative. Absolute value makes things positive, correct? So is there ever a case where an absolute value is less than a negative? Is there ever a case where an absolute value is negative? Never. So in this situation, if you see absolute value greater than negative, that happens all of the time. And so the solution would be from negative infinity to positive infinity. And just so we're clear, I'll give you an example. Suppose you had the absolute value of x was greater than negative 5. Well, just think about that. Even if you plug in a negative number, it turns it positive, and it's obviously going to be greater than the negative 5, right? Okay, so if you ever get a negative or a 0 on one side, you got to think about it. How about this one, an absolute value less than a negative? If the absolute value is positive, can it be less than a negative?
No.
No solution. Everybody from the other hours were saying no soul, no soul. Is that anybody else?
That's what I said.
Okay, all right. This one, absolute value is less than 0. What kind of numbers are less than 0? Negative. Can an absolute value be negative? No, so this is no solution either. We said an absolute value can't be less than 0, but could it be equal to 0? Yeah, so here there's one solution. And that's wherever x is equal to 0. Okay. If you look at this one, it says the absolute value of x is greater than or equal to 0. If it's got to be positive, it's always going to be greater than or equal to 0. So in this situation, we again have all real numbers from negative infinity to infinity. This one's the trickiest one of all. It says the absolute value is greater than 0. Is an absolute value always greater than 0? So this excludes one value. It's true for all numbers except it excludes one value, namely wherever x is equal to 0. So we'll put this into practice. You guys will understand this really well. We'll go through 2 examples. Letter C, I would like to solve letter C. So what should I do to both sides? Divide my 6 off. So I divide that 6, and I get the absolute value of x minus 5 is less than or equal to 0. All of a sudden, a bell goes off in my brain and says, oh, I've got a 0 on the other side. If you get a 0 or a negative, you should be aware of that. Okay? X minus 5, can it ever be less than 0? No, but could it be equal to 0? Yeah, so you just have one solution. So you just take this and make x minus 5 equal to 0. So your solution is x is 5. That's it. It's a one solution scenario. Look at your next one. I subtract 18 from both sides. And I get the absolute value of 2x minus 3 is greater than negative 13. Talk to your peer for 10 seconds. What do you think that solution is? Talk to your peer. Negative infinity to infinity, or all real numbers. The all real number sign, again, is an R with 2 lines on the front. Some people in the past have written IR. I don't know what that means, but that's not an I, but people will write that. They're just confused. So, all right, last example. Okay, what's different about here? X squared. So you got to take what you currently thought about inequalities, and you got to get rid of that. And you got to realize there's a different way that we go about solving it if it's not a linear inequality. And we have 2 things. First is a number line test. This went very well the last 2 hours. You guys are an extremely intelligent class, so it should go well for you. The first thing I do is I subtract that 15. Anybody want to guess what I do next? I do factor it to be x plus 5 and x minus 3. Now, do not write this down what I'm going to write now, okay? This is the temptation that exists for people on this problem. They set up x plus 5 is greater than 0 and x minus 3 is greater than 0. That only works if it's the 0 product property. This is not equal to 0, it's greater than 0. So this does not work. You can't do that. It's totally illegal, does not work out, don't try it. If you do that, this problem's worth 3 points on the test, I give you 1. Okay, you got 1 for factoring, that's all you've got so far. You want to get more points, you got to tell me some positives and negatives. You make a number line. Anybody want to guess the 2 numbers I put on my number line? 3 and negative 5. And then I test values. Connor, can you give me a number to the left of negative 5? Negative 7. Watch what happens when I plug in negative 7. Negative 7 plus 5, negative 2. So that's a negative number. Times negative 7 minus 3. That's a negative number. And a negative times a negative is a positive. I tested a number. Max, can you give me a number between negative 5 and 3? You chose 1. 1 plus 5 is positive, and 1 minus 3 is negative. A positive times a negative is a negative. Any number you test between negative 5 and 3 will be negative. Adrian, can you give me a number to the right of 3? 5. 5 plus 5 is positive, and 5 minus 3 is positive. A positive times a positive is a positive. Now, here's the key. Are we wondering where this inequality is positive, or are we wondering where it is negative? Which one?
Where it's
Why?
positive.
Why?
Because, it's greater than 0.
Yeah, look, you're wondering where it's greater than 0. So therefore, your solution set is wherever it's positive, from negative infinity to negative 5, union 3 to infinity. Would you like a quicker way of doing it? If you know what the graph looks like, you can make a graph and it will go more quickly. When I say graph, usually people are like, oh, no, trust me, you guys. Graphs make life better. And on my graph, I'm going to plot -5 and +3. What shape does x squared make? A parabola. Parabolas go like this. Is this a parabola that's going to be right side up, or is it a parabola that's going to be upside down? Right side up, because the x squared is positive. If it was a negative x squared, it would be upside down. So we're going to draw this parabola right side up. We say that if a parabola is above the x-axis, that's where it's positive. If it's above the x-axis, that's where it's positive. If it's below the x-axis, then it's negative. So notice how this inequality compares to what we just set up. You can see by the graph, it's positive from -infinity to -5, and then from 3 to infinity. That's where it produces positive values. It doesn't mean that these numbers are positive. It means if you plug in a number, it will make a positive. Okay? And so there you have it. Good job. This is going to take some time. So open up your homework so I can show you what you should best start working on for your homework. The first page is all linear inequalities. That should hopefully be nice straight up review for you. Okay, x to the first power. If you flip it over, you have 2 more on that side, and then it gets to the quadratics. A few of those quadratics you're probably going to feel really comfortable with. A couple of them, you might not as much. But so that would be good stuff to start on. Tomorrow when we start class, we're going to review the quadratics because about half of you will still be confused on it. If you can work on it, great. If you can't, then we'll get caught up tomorrow. Then we will be doing this afterwards. These are nonlinear inequalities, and they are definitely more challenging. So we're going to have to lean in when we get to that. And then you have all day Wednesday to work on this. Okay? You all good? All right, good job today.